Algebra 2 7.58, combinations of powers and roots, and I have a theorem for you. If you haven't seen the previous videos for Chapter 7, you might get lost or confused, and a link to all of those videos are in this video's description, okay? So what's the difference between these two? We've got the cube root of 8 squared, and we've got the cube root of 8, but our little 2 exponent is on the outside of parentheses. Well, when we do the cube root of 8 squared, that just means we have 8 times 8 underneath the radical sign, doesn't it? Which is a 64. It just means that something times something times something is going to equal that 64. And if we've got it in parentheses, it means we've got the cube root of 8 times the cube root of 8. Well, that's the same thing. We've learned that in the previous videos. We can put it under one radical sign, or we can have it underneath each of their own radical signs, can't we? It's still going to be the cube root of 64, which is still going to be something times something times something is going to equal 64. So here's our theorem. For any non-negative number a, any natural number index k, this root, and any integer m for our exponent, the kth root of a to the m power is still going to be the kth root of a with the m power on the outside of the parentheses. See that? We can raise a power to a power. And we can take a root, or we can take a root and then raise to a power. And one way might be easier for you than the other. It's up to you. It depends on how you're thinking and what you think is easier, okay? So we can simplify these radical expressions and then use our theorem to simplify another way. So we've got the cube root of 27 squared. Well, that just means 27 times 27, doesn't it? We do our math and we get 729. The cube root of 729 is 9 cubed. We can take away this 3 root and that 3 exponent, and we just get a 9. We can also do it if it's in parentheses. It just means that we can take this 27 and find out what it is cubed, which is a 3, because 3 times 3 is 9 times 3 is 27. And we can put it underneath the radical sign as a 3 to the 3rd power, because this is a 3 root and that's to the 3rd power. We can remove them, and the only thing that's left is this 3 and that 2 exponent. 3 times 3 is 9. See? So either way, we're going to get a 9. It doesn't matter if it's inside the parentheses or if this 2 is down here underneath the radical sign. See? Let's try it again. We've got the cube root of 2 to the 6th power. Well, that just means we've got 6 2's underneath here that need to be multiplied together, right? 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So we've got the cube root of 64. And to find out what that is, we have to find out something times something times something is 64. And that would be a 4 to the 3rd power. 4 times 4 is 16, times 4 is 64. See? So our answer is a 4. We can remove the radical sign with that 3 root and that 3 exponent, and we just get a 4. If it's on the outside of parentheses, our little 6, it just means that we've got the cube root of 2 times the cube root of 2 times the cube root of 2, like 6 times. See? And we can group them. We can put 2 of them together and get 2 squared, 2 to the 2nd power underneath the radical sign. See that? The cube root of 2 squared. And we can have 3 of them so that it ends up being the cube root of 2 to the 2nd power to the raised to the 3rd power. See, it's a power of a power. That makes that 6. 2 times 3 is 6. So you don't need to write this. I just did this to explain it to you. You could go from here to here. Just break up that 6 so we have a perfect root. All that's going to leave after we take off this root and that exponent, because they're both 3's, we remove our perfect cubes, is a 2 squared, which is a 4. See? I think this way is easier. Just to go from here to here, you break that 6 up to find a perfect cube. See? So you know what to pull out depending on that root, right? Whatever that root is. If it was a square, we'd have to pull out perfect squares. If it was to the 4th, we'd have to pull out perfect 4th roots, right? Okay, let's take a look at another one. We've got our little power of 3 on the outside of the parentheses, so that means we've got square root of 5x times the square root of 5x times the square root of 5x. We've got 3 of them. We can rewrite it so that we've got 5 to the 3rd power times x to the 3rd power under one radical sign. We need to pull out perfect cubes, or perfect squares, I'm sorry, because there's a little invisible 2 out here when we don't see anything, right? It's squared, so there's a little invisible 2 here. So we have an even root, don't we? And we can pull out 5 to the 2nd power and x to the 2nd power. See that? And it's going to leave one 5 and one x left over that has to stay underneath the square root sign because they're not perfect squares. we can remove this radical sign and those exponents because they're perfect squares, and we get 5 times the absolute value of x times the square root of 5x. And because that's an even root and we're going to an odd exponent, because there's a little 1 there, actually, that we don't have to write, right? When simplifying an even root to an odd exponent, we use absolute value bars on the variables, unless we know it's a non-negative. So we went from an even root 2 to an odd exponent 1. 1 is an odd number, and the x went inside absolute value bars. Now, if this had the parentheses underneath the radical sign, it just means that we cube the 5. 5 times 5 is 25 times 5 is 125, and we have x to the third power. We pull out our perfect square, and that would be a 25, wouldn't it? 5 times 5. And then we've got x squared, and that's going to leave that 1 5 and that 1 x left over that have to stay underneath the radical sign, and we end up with the same answer. So it doesn't matter if it's inside parentheses like this to the third power or if it's underneath the radical sign to the third power. See, we're going to get the same answer. Let's try this again. Now we've got a few more exponents. Look at this. Now we've got an x squared in here. So remember, the product rule says that we can multiply these together. So that's going to be x to the fourth, isn't it? And we've got the cube root of 9x squared y to the second power. So that means we have 2 of these, doesn't it? So what we can do is do 3 times 3 is 9. So we got 3 to the second power squared. We got a little 2 there, see? Our x is 2 times 2, so that's going to be x to the fourth power, and that's going to be y to the second power. We need to pull out perfect cubes because we have a cube root here, don't we? So this makes a 4, so that's a 3 with 1 3 left over. This is a 4, so we can pull out a 3 with 1 x left over, and that's not a perfect cube, so he has to stay underneath the radical sign. So now we can remove the radical sign around this 3x and remove these exponents. So we get 3x times the cube root of 3xy squared. And we don't need absolute value bars, do we, around that x, because that's an odd root. We only do it when there's an even root to an odd exponent. And this is an odd root, so we don't need the absolute value sign. See? Now, if the parentheses were underneath the radical, it's the same thing. This just means 9 times 9, doesn't it? That's an 81. And x to the second power times that 2 gives us x to the fourth, just like up here. And we have y squared. We pull out a perfect cube. We got a 27. And this x to the fourth can be x to the third with an x left over. 27 times 3 would be our 81. So what's left inside of here is the cube root of 3xy squared. We can pull this out as a perfect cube. It's a 3x times the cube root of 3xy squared. See? I think that way's easier. So it's up to you, okay? Now my advice is, because we're using so many square roots and cube roots, I would make a list of the square roots from like 1 to, I don't know, 10 or 15 or something, and then I'd make a list of all the cube roots, and I would keep them in your notes inside the cover of your folder or something, so that you could just click on them really quick and go to them, because these don't change. The cube root of 4 is always going to be a 64, and then you'll be able to flip your folder cover really quick and say, yep, that's it, and do your math a little quicker than having to figure it out every single time. Cube root of 8 is 512. Write that down. Eventually, you're going to get to a point where you might memorize these or some of them, okay? And you can do it for the squares, too, all right? So our next video is 7.5b. We're going to talk about rational exponents. So that means we're actually going to have a fraction for an exponent, okay? I'm going to add this video to the Algebra 2 playlist. I'm going to have links for the Algebra 1 videos that talked about this. We talked about rationalizing denominators and powers and roots in Algebra 1 last year. So those links will be in here. And all the Chapter 7 videos that we just did for this chapter, all those links are going to be in this video's description to make it easy for you. Okay? Everything's at your fingertips. All right? Doing my best to help you. And I hope you're doing well. I want you to keep trying. Take one little step at a time. Don't try to take off bite off too much. If you take one little step at a time, you can climb Mount Everest, okay? You could do anything, all right? I'll see you next video. Bye.